So working with common.NET types, your textbook you could almost have open as you look at this, because I kind of used our book to put this together because they just come up in this chapter with a lot of miscellaneous things. So we'll just look at them. First of all, they talk about working with numbers. We've worked with numbers a lot, right? You guys have worked with integers and doubles, and you understand what's going on there. But there are a couple of number types that we haven't worked with, and these are not things that you have to do anything with. These are things that are like FYI, for your information, this is available and this is out there. So it's not something that you have to have a deeply developed understanding of. Just remember that it's available. The first one is big integers. In their example in the textbook, they show us we have to bring in this system.numerics library to use the big integer type, and it's a U-long, unsigned long integer, and you can see they have this number here to parse the atoms in the universe, and they go out to 40 digits when they print it out. So that's for very, very, very big scientific number type calculations, probably like distances and things like that. So big integers are available for working with huge, huge numbers. And then complex numbers, I put this note down here to see if I could even say it, but quaternions, I put an extra N in there, quaternions are four-dimensional associative normed division algebra. So if you haven't had that class yet, don't worry, I don't know that it's offered here at OTC on four-dimensional associative normed division algebra. But if you are in that situation, you can use complex numbers in C#, and that's an actual data type of complex. So this would be something that you would use, say, if you were working in mapping software and you were like comparing different distances to determine which path you should take, those kinds of really advanced type applications where we're working with, complex series of numbers. So those are available if you get to that level of math. So far, though, we've just been working with doubles and integers and strings and decimals, and those are the kinds of data types that we normally use, like Boolean. If you worked for a company that was doing a lot of scientific calculations, then you would have a lot of example code available for big integers and things like that. So we're used to working with all of our different variables now. You guys are getting really good at it. We can have data. But sometimes we want our data to repeat. So what if we want to keep track of a whole bunch of people's names? Here in this example, we have like 5 people in our office that we would like to keep track of their names. Well, we can use an array for that. An array is also called a list. So you could see that same terminology. But right here is syntax that I would use in C# to declare an array of strings. So let's take a look at it here. If I had this line of code, notice the square brackets. The square brackets are what tell C# there's some array stuff going on here. Let's see what's going on. First of all, I start out by saying the data type of this variable is string, but then I follow that with square brackets to say it's going to be more than one string. And then I give my variable name. I named it name. That was really, industrious. And then I say, this is a new array of strings with 5 entries. Then some code has run somewhere that set these people's names into each of those entries. We'll talk about our indexes there as we go. After we've run that code, this is really kind of what we have in memory. We can think of it as a list like this. Some textbooks show the list going across. Either way is fine, just your representation. So when we look at this array, we see that besides the people's names, we've had a numeric value added, and that's our index. So our index is just an integer that's used as a pointer into our array. So it specifies a specific array entry. Our indexes always start at 0. So as programmers, we get used to starting to count at 0. Sometimes we have to stop ourselves when we're counting real things. The index value for the name Tammy in our array here is 2. So if I was wanting to refer to that Tammy value in the array, I would use the array name followed by the index value of 2 within the square brackets. And if I wanted to change Tammy's name, I would put the array name followed by the 2 or the index value in square brackets, and then an equal sign, and then the value I want to change it to. So after I ran this line of code, name sub 2 equals new name, Tammy's name would be changed to new name in my array. So notice how our code is accessing those specific locations. In these examples, the index value is hard-coded. Normally, we are going to use some sort of variable. There is our index value to indicate the location that we're concerned with in an array. So anytime we have a collection of data, we can set up an array to hold that data. Here's an array that is set up a little bit differently. Notice the line of code up here at the top that created this array. Here, this array is data type integer. You can tell that it's an array because it has the square brackets after the data type int. And this array is going to be named age. And in this array, I'm actually supplying the initial values for the array. So those initial values will determine the size of the array and what data is stored in the array. So in this array, this age array, I end up with all of these different ages at these different index locations in my array. Some things about arrays. In C#, these lists have to be allocated out of contiguous memory. That means memory that exists in a big chunk. So if I'm going to create a list of 1 million entries, it's going to use a big chunk of memory. And I need to be aware of that. My index value is always maintained by the system, and then the data value is something that we as programmers can change or set. So in this array, again, we saw that it was allocated at when this line of code was executed and these values were placed in the array. Let's do this little chunk of code down here at the bottom. Open, what do you guys want to do this in? Let's just do it in Replit real quick, because they don't think it's worth us opening a big old new project. So I'm just going to go to Replit, and I think it's working. Got past some of our bugs, and hopefully they've got their everything all good. I want to create a C#. And I'm going to name this L07 array beginnings. How's that? So this is just beginnings of array processing. There's so much we can do that we're just barely going to be scratching the surface. So I want to put this code in that was in the presentation. Let me see if I can get this over here. So in my main, I'm just going to have this line of code that sets up my array of integers. So I want to start out int and then open and close square bracket. Whoops, I'm typing in the console here. Let me get on my code. int, opening close square bracket, saying this is an array of integers, and it's named ages, and I want to start with these initial values, 16, 45, 29, 24, and 14. Now, after my curly brace that contains all my values, notice each of our values are comma separated. So we have a list of comma separated values here within our curly braces to supply the initial entries for this array. So how big is this array going to be? How big is it? 4 or 5? 5, right? It's going to have 5 entries. But the index values that for those 5 entries are going to be 0 through 4. Now, whenever we have that difference like that, it's common for us to be off by 1. That's the off by 1 error that us programmers experience a lot. So don't be surprised if something like that happens to you. Just remember, oh yeah, I'm thinking about comparing these things. Now I've got myself all messed up. Where's my presentation? So I want to make sure that I can find everything here. Come on, silly.
I think there might be something wrong with the report.
Is it being wacky?
It is being wacky.
What's it doing to you?
Blank error. Oh, if I hold over it long as it represents a 32-bit signed integer, I can share my screen.
Yeah, share it. See if I can get it to display here.
Here it's yelling at me because of whatever's in here. If I hover over it says represents a 32-bit signed integer, and it also shows me blank errors for some of it. I don't know what I did. I broke rep.
Do a space after your commas.
Okay.
Let's try that. Is it still complaining at you? Can you zoom in a little bit?
Yes. So.
Anybody see anything?
Don't you have to declare a new array, variable equals new array?
Not when you're supplying the values. This is the correct syntax. So we'll just see what happens. So hang on, go ahead and stop sharing for a moment and let's see if we can figure out what's wrong with it. We'll add a couple more lines of code and see if it keeps griping at you. Maybe it'll settle itself down sometimes. All right, so I would just want to do some right line statements. So let's do using static system.console just to make it easy on ourselves. And then I want a right line. And the first one that I want to output is just going to be our ages variable. And I want to output the one at index entry 4. So that should be 0, 1, 2, 3, 4. I should see the 14. Now let's run that. Does anybody else get any weird errors? Oh, am I not sharing again? Thank you. Is that better? Mine's just taking forever. It's not actually doing anything.
So it'll run with those red text boxes, but they still are there.
know what it's doing. I think it's just very confused. But mine is not running. How's everybody else doing? Is it running? Being a jerk? Well, that one, I promise, should print out the number 14. 0, 1, 2, 3, 4. So let's put another right line statement in here. And then we'll walk through it since it won't let us run it. If I print out the ages at index position 0, what value should I see? 16, that's right. What if I print out the ages variable at position 5?
Error.
Will it let me run it that way?
No.
It'll run, right? It'll give me a runtime error. So you're right on it. Being real picky here. So that would not give us a compile error. The compiler will not be able to tell that you've gone out of bounds on an index entry, even when you have it hard-coded like this. So it's going to go ahead and compile, but then when we try to run it, we would cancel and get a runtime error saying that our index value was out of bounds because it was too large, bless you, for the size of our list. It's not going to run it. So I'm just going to minimize this and go back to our presentation, and we'll go back to it in a little bit and see if we can get it to be more cooperative, or we'll switch to Visual Studio Code and see what kind of errors it can give us today. All right, so our collection here, we see that our syntax is a little different when we supply the initial values. So we don't have that. And here's the error we'll get, an unhandled exception that we were outside of our array. So syntax. If we want to create an array and initialize it, we will specify the data type followed by square brackets, then the name of the variable, then an equal sign followed by the list of values separated by commas within curly braces. So this is our array with initial values. Now, if we want to access one of the entries in our array, our syntax is array name followed by the index value. So here we allocate a variable to hold the age entry, and then we set that variable equal to the age at index position 3 in our array. We can consider that 3 an index pointer, a subscript, all sorts of different names that you might hear that index value referred to. Now our one-age variable, after execution of this line of code, would be containing the data that's currently at position 3 in our array, 0, 1, 2, 3. So the value 24. And we do that often to save a value as we're manipulating arrays. Now, when we're working with arrays, we have a special variable, a property called length. So if I want to know the size of this array, I can refer to the array name dot length, and that'll return an integer with the size of the array. Here, there's the syntax to update an array entry, all sorts of things. All right, so here's a flowchart. Common things that we might do with arrays. One thing is that, especially as a student, you might be asked to load an array with random numbers. So here's some code that I could use to do that. I could say I want to set up an array of integers. I'm going to call it ARR, and it's going to be a new array with 100 integers. And then I could go into a for loop, and in my for loop, the variable that is controlling my loop, I could use as my index. I'd start it at 0, and I'd say that I can run this loop as long as it's less than the length of my array. And while it's less than the length of my array, I can add 1 to it every time I execute the loop. And then within my loop, I could use the random number generator, which we haven't really looked at yet, to generate a random number and save it in that array location. So we will definitely, if we don't get to do that today, we'll definitely do it next time. Create this code to load up an array with some random numbers. Now I have a question for you. When you're looking at this C# code, length is something that is a meaningful term within C#. And is length a property or a method? How could you tell? That's right. Doesn't sound real sure, but that's absolutely right. And the way we can tell is There's lots of ways. We could go to the documentation would be the best way. But a property doesn't have an open and closed parenthesis after it, right? Because it's just a variable that's contained within this C# array class. Whereas a method always has the open and closed parentheses following it, because this is a method within the random class. So we can start noticing those differences ourselves and being aware of, oh, I'm working with a property here, or I'm working with a method. So that's just helpful for us as we're coding. Here's a flowchart that shows this loop to build an array with random values. We start out setting an integer named I equal to 0. And if I is less than the length of our array, we set the array value at position I to a random number, and then we add 1 to I. And we continue in that loop. So that's kind of a visual of our for loop there. Now, working with text, whenever we're working with a string, we're actually working with an array of characters. So C# makes that definition for us back behind the scenes. They also have synonyms set up so that if we say something is a string with a lowercase s, that will work. If we say it's a string with an uppercase s, that will also work. So you might not notice that right off the bat, but C# does have that synonym set up, so either one will work as a string. But when I'm working with a string, I'm actually working with an array. So here's my name down here as an array. So if I wanted to look at this, I could say, first of all, my name has a length of 11, right? Because the whole thing altogether would be 11 characters. And if I wanted to figure out some things about my name, I could. Like if I wanted to know what the very first letter was, I could always use that index location 0. Or if I wanted to maybe split apart my names between my first and my last name, I could look for a space character and say, separate them at that space character, because that's my first name and my last name. Lots of things we can do with strings and as arrays. So here's some examples from our book. First of all, they create a string named city and set it equal to a value of London. Then they write out our city, and then they use that length property to tell us how long that city name is. So we could do that. Next, they write out a line telling us what the first character is of the city name and what the third character is of the city name. So again, we've seen, okay, that's how we access those different index values. Now, here are some more advanced things that we can do with strings or with text. Besides having our city length, we could split up a string. So let's look at this example down here in the bottom. Here we have a variable named cities, and it's just a string, but inside of that string, there's a bunch of comma-separated values. We may have read these in from some file, or maybe some website or something where we're seeing all these different comma-separated values. We can use the split function to split those values into an array of cities. So after we execute this command, cities.split, our cities array will have 1, 2, 3, 4 entries, and each of these cities would be a separate entry in our array. So the way the split command works is we specify the variable that has a string, and then we use .split as our method name, and then we pass a parameter of the character to be used for the split. In this case, it's a comma. Now, after we've split that array, we can use a special version of the for loop to process all of the arrays in that entry to write them out. And that's called the for each command. I do want to practice this one. So let's see if anything is cooperating. Oh, it did finally run. It did finally give me my error. So I'll try to do this cities array. If you have this code in Replit, comment out line 9, because that one causes an error. That's our out of bounds. And then let's create this new string called cities. And they have Paris, Berlin, Madrid, and New York. I left out Berlin. Now, notice there's no spaces between these cities for our split command. Everything's squished right up against each other because we're not wanting to look at spaces for this. We're wanting to look at the comma. Now I'm going to create an array of strings. So I'll use the string data type and then my open and close square bracket. What did they call this thing? Cities array. And my cities array is going to be based on this cities string. I want to split it every place there is a comma. Now our cities and array entry should have 4 entries. Let's write out our length and make sure that's correct. Cities array has cities array dot length entries. Now for this one, I need that to be an interpolated string since I set it up that way. So I'll put my $sign there. And now I want to print out each entry. Print out each entry. So I'm going to use this special for each loop. The for each loop is built to work with arrays and collections. And I could use a regular for loop, right? We saw in our presentation earlier, I could set up an integer named whatever and start it at 0 and run until it gets to be the length of my array. But my for each loop makes it to where I don't have to go to all that trouble. The way the for each loop works is I'm going to have open and close parentheses after the for each keyword, and then I'm going to specify a variable to hold each entry in the array. Ours will be a string, and we can call it city. For each string named city that you find in the cities array, I want to do something. And what I want to do is just print out that city. So let's run. See if it'll do anything here for us. Since it's being so slow, I'm going to go ahead and open Visual Studio Code. Oh, there it finally went. So we can see that we've got our cities array has 4 entries, which is correct. And then each of them gets printed out. I'd like to run it in the debugger so that you guys can see how the for each command works. So I guess Visual Studio Code would be better. In Visual Studio Code, if you could get yours open, I'm going to close this project that I currently have open. And I'm going to do File, Open Folder, and go to my code repository. I'm going to create a new folder called Chapter 7, or Chapter 8, sorry. And then in my Chapter 8 folder, I'm going to create one for this one. We'll call it Array Testing. I'm going to use that folder finally. And then I'm going to enter my .NET command to create a project. .NET new console / framework, well, -- sorry, net 5.0. Everybody's work okay? Project. Click on your program.cs and wait for that little magic pop-up saying that it has things to add. There it is. Yes. Add them. Now I'm going to take my code just in my main. Bless you. So I'll just copy the code in my main. I'm not going to get the curly braces for my main, just the code within it, and paste that here, just within my main. And then I'm going to select it and tab a few times to indent properly. I've got some errors because I don't have my using static system console. I'll get that set up. And then one last thing, my right line statement here on line 22 is not indented properly, so fix that. Copying and pasting things. So I'd like to see this in the debugger. So I'm just going to press F5 to start running with my debug. And I've got the whole thing ran, nothing going on. So I better set a breakpoint if I want to see anything in the debugger. I think I'll set my breakpoint here on line 14, where we allocate our string of cities. So let's run that again. Let it stop at the breakpoint. Now, over here in our variables, notice our cities and our cities array variables are both null. We haven't actually executed this line of code yet. So if I run it, we should see our cities now has a value. And now this line of code on line 16 is going to do our split. So after we execute it, we should have values in our cities array. Let's do it. Yep, there our cities array now has values. So I'm going to expand those, unfold them, and I see my whole array. So this is a really, really good display that we get out of Visual Studio Code that I haven't found in any of our other development tools. It's very nice that it displays all of our array entries this way with our index value. So notice how that split command took care of making each of those into their own entry. Now I'm going to do my right line statement to output how long the array is. And I should be able to mouse over that variable and see that value too. And now I'm going to go into my for each command. In my for each command, I'm saying I want to create a new variable called city for each entry in the cities array. Run it here. Notice how the yellow little rectangle thing focuses in on our array name. And it says, oh, you want each of these. Okay, here's one. So the first time through, my city variable that's in my for each loop gets set to Paris. I'll run and print that. And now I'm going to set a new city variable equal to the next city in the list, Berlin. We'll print it. We'll set our city to our next entry in the loop, Madrid. We'll print it. And then finally our last city in our loop. And we'll print that out. So the for each statement is really, really handy. Now, notice though, when we're working with the for each statement, we don't know what the index value is for each of those array entries. We just see the entry itself and we can process it. Any questions about that? Did everybody's code work? Did you get it? Okay, okay. You can see how it's handling those array values. We use arrays and collections so much and in such advanced ways in C# that it's really good for us to really get an understanding of how they work internally. Okay, so those arrays that we've been looking at, those are called lists. There are different types of collections. Anytime that we have more than one thing in C#, we call it a collection, and our basic type is an array. When we're working with this list or array, we can manually control the order of our items that are in our list. A unique index for each item is automatically set up, and duplicate items are allowed. They're just fine. The system doesn't care. We can also use dictionaries. Dictionaries are more key value pairs. So whenever we're looking at a dictionary, each value has a unique subvalue or key. So this displays a really small dictionary with just a couple entries. But if I'm looking for Bob Smith, I could use the key BSA. And if I'm looking for Max Williams, MW. So the dictionary kind of eliminates the index for more of a unique key type situation. To use a dictionary, we must implement the iDictionary interface. And dictionaries are pretty new in C#. This is something that's a rollover from Python. So something that will definitely develop and get better as time goes on. There's other data structures that are collections that we will hear of and use as time goes on. A stack is like a stack of plates at a buffet. The last plate that was put on the stack is the first one off the stack. That's why it's LIFO. So if you walk up to a buffet, there's a whole stack of plates. You take the one off the top, well, unless you're some, I know that Karens take two off the top and set them off to the side and then take that third one or whatever. But anyways, that's LIFO, last in, first out, a stack. We could also have a queue. A queue is just like standing in line. We hope that the first one in is the first one out. They're at the front of the line, so a little bit different than a stack. And we can also have other data types like sets, and sets work really well if we have multiple collections that we're wanting to compare to each other. These advanced data types you'll look at in the data structures class and in your advanced C# or Java classes. So you'll see those as time goes on, a little bit more about them. Now, some other things that we might run into in C# are spans, indexes, and ranges. They all have to do with arrays and collections and lists, though. So a span is basically a part of an array. So this allows you to work with a subset of a collection. And I've mentioned a few times, think about having an array with 1 million entries. Your company has 1 million employees, and they're all basically in a collection. But you only want to work with the employees that are within a certain pay range or something like that. Well, you're able to work with a clump, a section of your collection. So your collection will have to be sorted in a way that allows you to work with that group. But working with a span or a part of a collection is much more efficient than copying the whole collection or just the part of it that you need into a whole new one. So in order to accommodate this, indexes have actually become a data type in C#. So in some older versions of C#, this was not the case. You wouldn't have this capability. But now we can actually say that a variable is an index. And in this case, they even gave it an initial value of 3. And then we can also define a variable as an index data type equal to 3 with this kind of syntax. So 2 completely different syntaxes to do the same thing. And then we can use that index value if we want to. Here's one. This second set is allowing us to access an index value counting from the end of the list. So if we're using this long syntax, we can say the value of my index is 5, but it's from the end. I could also do a shortcut by using the caret symbol and the 5. So that says from the end. These indexes that come from the end of the array are confusing to me, but they're very usable because sometimes we just want to get the last entry in an array. That's a real common thing. So these are something that are new, and you won't see a lot of use of them currently in the field, but that doesn't mean that they aren't a great thing to try. Okay, so we say that we can use a span, which is a part of a collection, by setting things up using this index data type. We can actually define ranges of an array. So in this example code, they've defined several different ranges. Range 1 starts at index entry 3 and ends at index entry 7. So that would mean R1 is a new collection that just has those entries. All of these lines of code attempt to do the same sort of range. So again, these are FYI, they're out there and definitely something that you can use if you see a purpose. And then the last thing in our chapter that, well, it's not the last thing, there are some other miscellaneous things, but there is some information on accessing network resources. So to access network resources, you use the system.net library. They give you some examples in our text of how to access a specific URL and then gather information about that URL. And they also show you how to ping a server. So we don't want to do any ping flooding, but the code is there in your textbook on page 280 for you if you want to try accessing some network resources. One other thing that's in our textbook is accessing images, a whole list of images, and that's something that you could definitely try on your own. It's pretty new, and we're going to focus in class on making sure that we have a really deep understanding of how our arrays are structured and work.